Hey guys, BuildZoid here, and today we're going to take a look at the voltage mods that I have on my 3060 Ti. So by that I'm referring to the memory voltage mod over here, and the core voltage mod over here. And I guess we'll start with the memory voltage mod, because between the two of them, that's the only one that that's arguably the more useful one for 24/7 operation, as increasing the core voltage of a 3060 Ti on air cooling or, well, water cooling you might see some benefit, but on air cooling the benefits are extremely minimal and the increase in power consumption is kind of ridiculous. So we're not going to be looking at we're not going to start with the core voltage mod. This is really useful for like sub-zero overclocking, so like dry ice, liquid nitrogen type cooling. But for ambient, yeah, don't bother. Like, it's really not going to get you anywhere. This, on the other hand, on my card, so my card uses GDDR6 memory chips from SK Hynix, and what's kind of wacky about these GDDR6 chips is that they are specified to operate at 1.35 volts, but they overclock significantly better at 1.25 volts. And so this mod actually allows me to both raise and lower the memory voltage. And so the current configuration of that is that the voltage is lowered. My card runs the memory at 1.25 volts thanks to that modification over there. Yeah, it's currently sitting in my daily system, and these are the settings that it's running. That's not necessarily maxed out, but I've not felt like actually going and like dialing the card in super hard because it's a 3060 Ti. These don't really seem to be particularly starved for memory bandwidth. Anyway, so let's take a look at how that memory voltage mod works, because oh no, did I seriously put away that folder? Oh no. Damn it, BuildZoid. Okay, wait, found it. So yeah, the memory voltage mod is super simple. It's literally just two wires going from the UP16. So this is on the front of the card. This is the other side of the card. We literally just have these two wires on the UP1666 voltage controller over here. So this wire over here, this is 2 volts VREF. And that is connected to this pin over here, and we know that because if you look at the documentation for the 1666, which is public, you can get to it through the UPI Semiconductor website, which unfortunately, according to Google Chrome, is not secure because component manufacturers have horrible websites. So, like, this is actually pretty good. Some of the like capacitor manufacturers, like, their websites are great. Absolutely incredible. Anyway, so UPIs is easy to navigate, but not safe, apparently. Yeah, here's the controller, and for orientation, you have this dot right here, right? So that corresponds to this dot on the card, right there. And then if we go back to the documentation, our pins that we care about are VREF, REFIN, and REFADJ. Well, actually, we don't care about REFADJ. For the 3060 Ti, the memory voltage always sits at 1.35 volts. So as far as I can tell, my card just doesn't seem to use the REFADJ pin to do, well, anything. So we don't actually have to worry about that pin on the 3060 Ti Gaming X that I have. I'm not sure if, like, there's 3060 Ti's out there that actually do use the REFADJ pin, but mine doesn't, and I would assume most don't. But anyway, so ref in, this is the pin we actually care about. Basically, whatever voltage you apply to the ref in pin is the voltage you get at the out, like, that's the voltage you're sort of setting for the VRM. So if we apply 1.2 volts to ref in, then the VRM is going to output 1.2 volts. If we apply 1.4 volts, VRM is going to be set to produce 1.4 volts. In the stock configuration of the card, the ref in pin is connected to VREF, which VREF is a 2 volt output, through a set of resistors that sets the ref in voltage to 1.35 volts. And that sort of looks maybe a bit like this. It's not actually like this example circuit is actually not accurate to the 3060 Ti whatsoever, but like this gives you the idea. Like, the REFADJ on the 3060 Ti I don't think is actually used, but you can see how VREF is connected with this resistor over here to ref in, and then there's also a few more resistors, and ultimately at some point it connects to ground, which is VSS SNS. Oh, actually, yeah, that should be ground. Just gonna get the pin definitions. Like, VSS is ground. Yeah, like that's just ground over there, right? VSS SNS, and if you look over here, that's ground. So I do remember that correctly. I was expecting just a ground symbol there because that's what some documentation does, but whatever. Anyway, so yeah, the only thing we really care about is like the resistance between VREF, ref in, and ground. And actually, we don't even really care that much about that. Like, I've already measured those, and I've forgotten them. I think I have them written somewhere on a bit of paper. I might have already thrown that out, though. So, anyway, it doesn't matter. So we attach our wires. So obviously ref in is connected to these components over here. The wire that I'm using, this is 0.1 millimeter solderable enamel wire. This stuff is really cool. So it's enamel coated wire, but unlike other enamels that I have experience with, you can solder through this stuff. Like straight up, just the heat of the soldering iron is enough to sort of break down the enamel. So wherever, like, you don't have to strip it or anything. I have other enamel wires where it's just like if you try to solder through the enamel, the solder just doesn't freaking stick at all. But yeah, this stuff, you just kind of, like, you just treat it like it's not coated in any, like you treat it like it's uninsulated wire as far as soldering is concerned. So yeah, so this is where, you know, I get the connection to ref in. This is where we get our connection to VREF, because the VREF pin over here goes to this via, and that just dives into the board, and then I guess it comes out over here in this area. Actually, I think that's exactly what it does, is just like we have this via over here. There's a few more vias, but I think it comes out from this via. I'm not 100% certain. And then through a series of resistors like this one over here, and I think like this, I think ultimately this one, and maybe this one as well, it ends up connecting to the ref in pin, and then some resistor connects ref in to ground. And that lovely collection of components sets the stock voltage to 1.35 volts. We don't really care about that. We just want a connection to ref in and then a connection to VREF. So on the other side of the card, on the back with the actual memory voltage mod, which we have a close-up of that. So VREF connects to this leg of this potentiometer. That's a 10K ohm potentiometer. Then the middle leg of that potentiometer connects to this 2.2K ohm resistor. I'm using this 2.2K ohm resistor to ensure that the memory voltage can never exceed, I believe, 1.4-ish volts, something like that. I've not actually checked where it maxes out. There's no reason to. Yeah, that resistor is just there so that, let's say you put the, like, let's say you had the potentiometer turned all the way in one direction and you installed it backwards or whatever, you wouldn't send 2 volts to the memory, because if you send 2 volts to your memory, bye-bye memory controller, nice knowing you, and your card is dead. So don't send 2 volts to your memory. So that's what that resistor is there to do, is just to ensure if I screw up, I can't screw up so badly that it causes, like, very quickly destroys the card. Like, this is probably, well, 1.4 volts is probably fine. Like, on, say, Samsung GDDR6, I would be very surprised if, like, it didn't scale all the way up to even maybe 1.5 volts. But SK Hynix GDDR6 is weird in that it actually doesn't like even 1.35 volts, which is the stock voltage. So, and potentiometer also has this connection to ground over here, right? This is the ground side of a molded SMD capacitor. Fun fact, these have like you might be used to the marking on like through-hole capacitors indicating the ground side. No, on these that's the positive end. Anyway, so yeah, that 10K ohm potentiometer is also connected to ground, and then that 2.2K ohm resistor goes to this switch over here. And then this is where ref in connects. So all this switch is handling is basically in this position that we have the switch in the photo. The modification is turned off as there's no, like, these two pins aren't currently connected together. And then when I want to turn the mod on, you flick the switch and it connects the potentiometer through the resistor to the ref in, and, you know, the mod is active. And then you can turn the potentiometer up and down to adjust the voltage level. I believe the lower, actually, this doesn't have a lower voltage limit, which is a bit awkward. Like, I could potentially set the memory voltage to like 0.5 volts or something stupid like that, but the memory doesn't really work below 1.2 volts anyway. Like, if you start pushing it significantly below 1.2 volts, it starts having all kinds of issues. So, yeah, there's not really any reason to that. But the thing is, setting the memory voltage too low isn't going to really, like, that's not going to cause damage, in my experience at least. I'm not saying that definitely will not cause damage, but my personal experience with breaking things using volt mods is that normally you have to raise the voltage too high rather than too low. If the voltage is too low, things just kind of don't turn on in the first place, and, well, they don't turn on, and that's kind of the end of that. So they don't run, but they don't break. Whereas too much voltage can definitely break things, and that's why there's that 2.2 k ohm limiting resistor, as I like to refer to it, because it limits the maximum voltage that you can set with the modification. So yeah, that's the memory voltage mod. Pretty nice and simple, and you can adapt this methodology to basically any other GPU that uses a UP1666. If it has a 1666, you've got a VREF pin and a ref in pin. You need to, like, ideally you want to trace those out to somewhere where it's convenient to connect to them. Like, yeah, you could solder directly to the pins, but I don't really recommend that. It's not very fun, very, very tedious and fiddly and unnecessary. If you, like, just take your multimeter, trace the pins out to, like, the nearest SMD component, especially, like, VREF has to have a capacitor. Like, yeah, like, VREF has a capacitor attached to it. Always. There's always going to be a capacitor with 2 volts sitting on it near one of these UP1666s, because that's just how you're supposed to implement your VREF. Like, literally, typical application circuit right there, you see this capacitor, you just kind of look for that, which is basically what I found on my card. That big capacitor that I'm grabbing my VREF from, that's the equivalent of this capacitor over here. And then for ref ADJ, actually ref ADJ we don't care about, but ref in is connected to VREF through a resistor. So you don't have to solder to the ref in pin. You can solder to the ref in resistor, and that'll make the process a lot simpler, or a lot easier to do the soldering. Though I do highly recommend that, like, 0.1 millimeter solderable enamel wire. That stuff is amazing, because you don't have to worry about, like the 3060 Ti I have, I'd say this is actually really nice. Like, this is super convenient. Like, there's not a lot of components in the way of the connections, right? Like, there's literally nothing here, right? There's no components right over here. So the wire just sort of comes in, like, in a straight line, and it's really nice and tidy, and the VREF capacitor is in the middle of freaking nowhere. Right, it's as about, like, there's really lots and lots of space to work with. So this is really nice. But sometimes you have a UP1666 that's in the middle of, like, the SMD component hell that a lot of NVIDIA cards come with, because, well, they just kind of do that. Mostly because a lot of NVIDIA manufacturers like to have PCBs where you can swap out controllers and that kind of thing, and so they'll have, like, a bunch of optional component mounting points that aren't used. And that makes things really awkward if you're soldering, like, thicker wires, because you have a lot of very densely packed components together, and then it's just, like, making sure that you only connect to the thing that you're trying to connect to and not everything around it as well. So, yeah, anyway, that's the memory voltage mod, you know, nice and simple. And then we have the core voltage mod, which is a bit more complicated and also not really that useful at ambient. So, here we have our chip. This is a UP9512R. All you really need to know about the UP9512R is that it is a 8-phase buck controller with an SM bus. So technically you can use digital voltage controls on it, but if we look, I think there's it's a bit dumb. It's like the SM bus on this thing is kind of like a bolted on afterthought. It doesn't really give you that much. It doesn't really give you that many useful capabilities. I really do prefer using modifying the ref in pin like this. Also because, like, if you crash out of a benchmark with the mod that I have, like, you don't have to worry about, like, setting the voltage correctly again. The card boots at whatever voltage you crashed at. So I really do prefer that. Also, some cards will actually have the SM bus, like, write protected or just disabled, and so it's just easier to mod the ref in pin, because NVIDIA GPUs rely on that that ref in circuit. That is how they work. That is what they use as standard to operate these cards. So that always works. Whereas messing with the digital controls for this controller is kind of like, I don't know why you'd bother. Like, you can, but it's like, if you're already soldering wires to the card, just freaking use the ref in pin. Way easier. Anyway, so we've got the same freaking example circuit as before, and the theory is the same, except this time we do have to deal with ref ADJ, and if you want to keep the card dailyable, like I did, you kind of need to do a little bit of, you know, like, you can't just remove ref ADJ, because if you just remove the ref ADJ resistor, the card is locked at static voltage permanently, which is not very convenient. So, yeah. Oh, and the other thing I wanted to mention about the UP9512 is that there's a bunch of different variants of the 9512. So you have the 9512R, which is what's on my card. And the thing that like defines the 9512R is it's an 8-phase and it has DCR current sensing. Then you have something like a 9512Q, which is a 4-phase variant of the 9512, and also has and this one has a ref out voltage for smart power stages. So this doesn't use the DC resistance of the inductors, it uses the built-in current monitoring functionality of smart power stages. So this one is meant for like smart power stages. Then you've got like a 9512S, which is a 4-phase but with DCR. So this is like a common one for memory VRMs on like high-end cards like 3080s and 3090s. And then you have a 9512P, which is, you know, with like an 8-phase with support for smart power stages again. So that's sort of the only differences there. I believe they all use, like, the way the ref in circuit works on all of them is exactly the same. The 4-phase ones, I think, have it in a slightly different location. The 8-phase one is exactly the same. Right? Yeah. Ref in, it's right down by that corner. If we look at the 9512Q, should have maybe zoomed in on that. Yeah, so ref in is at like the pins that you need to mod are slightly different than usual. That's the only difference for that one. Anyway, I have a 9512R, so we're going to take a look at the 9512R. And so we've got our pins of ref ADJ, ref in, vref. Obviously, we are not going to solder directly to the pins because that is stupid. I mean, you could, but I'd say that's just making your life more difficult than it needs to be. And so here's what I've done on my card. So the first thing we need to do is deal with that ref ADJ, because if we're going on liquid nitrogen, the last thing we want is the NVIDIA driver controlling the core voltage. We do not want the NVIDIA driver controlling the core voltage. So normally, this resistor right over here would not be at this angle that it's at. Normally, it would be straight up like this. It would be connecting this pad to this pad. And of course, it's not doing that on my card because this resistor is connected to the ref ADJ pin, which, where is that pin? Yeah, that's pin 40. So that is this pin right here. So this pin, you know, this pin over here connects to ref AD, like connects to this resistor. And so I've put that resistor at a 90-degree angle because there was a bunch of empty space in this area, right? Oops. Like we have all this empty space in this area for activities like 90-degree resistor rotations. If there wasn't a bunch of empty space right here and we had a bunch of SMD components, I would have just tombstoned the thing. Like I would have just had it sticking straight up off of the board. And then we attach a wire to it. And now we have our manual connection to ref ADJ. And then we have another connection over here with another wire. And this is very simple. This just goes off to a switch so that I can effectively connect and disconnect the ref ADJ pin from the ref in circuitry. So on the actual mod, that is this switch over here, and you can see, you know, like the wires coming down to roughly, you know, where the stuff is. So yeah, all this does is just reconnect and disconnect the ref ADJ part of the circuit. And the way it does that is I rotated that resistor 90 degrees. And you do kind of want to keep this resistor because the value it has is like very awkward. Like it's not a standard resistor value. Like it's a very specific resistor value. So you're not just going to like replace it with something and have your voltage correct. If you replace it with the incorrect value, your GPU voltage is going to be skewed either up or down. So you really want to keep this resistor as far as I'm concerned. You do not want to be trying to find a replacement for it unless you measure it. right? Like, I guess if you measure it, then sure, you can lose it, but I think it's better to just keep using that one. And I've not measured it, so I can't tell you what the value of it is because I didn't bother to measure. Or more like, I measured it, I realized that there's no way I'm finding a replacement for it, and from then on, I just like made very sure to not lose the damn thing until I got it set up in this configuration over here. And so that's how we deal with the ref ADJ part of the circuit, and then over here we have a capacitor. I wonder what that could possibly be for. Of course, it's the 2-volt VREF circuit. Now, fun fact, I'm pretty sure this pad is either ground or ref in, both of which are really, really bad news, of which ref in is the worst news, because if you connect this, like if you connect this right here to this pad, and that pad is ref in, and I'm pretty sure it is, you are going to blow up your card. If you're lucky, the VRM won't even start properly, but probably it'll boot up at 2 volts and kill the core. So, yeah, if you have like if your wire is too thick, don't try to force it here because you really don't want to bridge this to this. Okay? Honestly, I'm surprised that MSI designed the card like this. Like these two pads being so close together is just, yeah, I'm really not a fan of that. That is just like, that is terrifying. That those are close together. Now, obviously, if you're not modding the card, then like nothing really should go wrong with it. But I don't know, if you had like a conductive speck of dust land right there, bad day, very bad day. But I guess you shouldn't really be like, you know, don't cut metal near GPUs. But that kind of goes without saying. Anyway, and then over here we have the ref in connection. So that's literally the same deal as before, right? We have connection for ref in over here, vref over there. Ref ADJ disconnect is handled through this mess over here. And then if we switch over to the actual mod itself, we have a 10,000 ohm resistor for limiting the max voltage, which I believe is limited to like 1.3-ish volts. This is a 100k ohm potentiometer. Because at one point in time, I was actually considering using the volt mod at the same time as the stock voltage control to sort of have like a positive voltage offset instead of full static voltage. But the thing is with offsetting the voltage on NVIDIA GPUs, if you start raising the voltage too much, the driver just starts compensating for the positive offset, so you don't really get anywhere doing that. So yeah, I've never actually, like, technically I could use it to do that, but I've never actually done it. So that's why it's 100k, because if you use it at 10k and you wanted to use it for a positive offset, it would actually, like, your initial offset would be really, really high. Whereas with 100k, you can actually have like a very fine control, small offset. But if you're just going for static voltage, a 10k ohm resistor would have worked. I mean, 10k ohm potentiometer would have worked just fine as well. Anyway, actually, would it? I think 10k would be fine. You might have to like tie it to ground on one leg or something, but anyway, then we've got a switch, and you know, potentiometer connects to the switch, not through the resistor this time. Like, the thing is, the resistor is in series with the potentiometer and the switch, so it doesn't really matter where each of the components is. Just kind of, as long as they're in the chain, the order doesn't matter. Yeah, you know, series resistors just, and a switch. So like the order doesn't matter here. It's just kind of, I found this convenient in terms of attaching everything to the card. So potentiometer connects to the switch, and then the switch connects the ref to the ref in resistor, and that's, you know, switch connects and disconnects the potentiometer. That's all there is to it. It's super simple. Obviously, it also completely destroys your warranty, but as far as actually doing the modification, very simple. Also, you need a pretty fine tip soldering iron, and you're going to want flux. And preheating helps, though this card doesn't really have a very heavy PCB, so it's not too bad in terms of the soldering, especially in this area where you just have a bunch of fine SMD components and not a bunch of like power planes or anything. So yeah, that's the volt mods on my 3060 Ti. I mean, you know, like core voltage with the option to go back to stock voltage, like to completely stock voltage operation, which is how it's running right now. And then memory voltage, which again, you can just go back to stock. It doesn't need two switches because the stock circuitry is not, you know, you don't have to disable the ref ADJ part of it, because it's not used for the memory. And that's it. That's all there is to the volt mods on my 3060 Ti. For the actual voltage monitoring, I have these connectors over here. So I just have these like nice small little voltmeters that I can just hook up to those. I mean, you could also, I could adapt those connectors to a multimeter probes as well and whatever. So yeah, but that's my voltage read points. This is not super accurate. These read high. Like, this is way too close to the VRM relative to where the core is. So this reads significantly higher voltage than what you actually end up with at the GPU. But that doesn't really, like, the point of this voltage read point for me is not so much to know exactly what voltage the GPU is at. It's more for me to, know if I'm raising the voltage or lowering the voltage, and if I've raised it by 50 millivolts or lowered it by 50 millivolts. That's all it's there for. I don't actually care about the absolute voltage value itself. I just care about in which direction I'm adjusting it. And so having a voltage read point that is inaccurate in such a way doesn't really matter to me. Yeah, especially since if you're setting the voltage at idle, the difference between this read point and the actual core is going to be minimal. It's only under load that it starts becoming an issue, but you shouldn't really be changing the voltage while the card is running a benchmark. I mean, you can, but I don't see the benefits in doing that if you're on static voltage control like I am. Maybe if you're messing with offset voltage control, then yeah, you might want to do it under load, but even then, you're still mostly concerned about, like, did I offset the voltage by plus 10 millivolts or plus 20 millivolts or 30 millivolts? And you'll see that just as well if you're over here as if you were over here. So, yeah. Anyway, there. Okay, that's actually it for all the volt mods on my 3060 Ti. Yeah, you can probably replicate this to, like, I think MSI actually uses this PCB for their 3060. And this PCB is also, like, the principle behind all of these mods applies to literally any card that uses a 9512 and a UP1666. So bunch of 3070s, 3070 Ti's, 3060s, 3060 Ti's. You're just not necessarily going to be able to rely on, like, the exact same component locations. You'll have to trace out the components yourself from the pinout of the controller. So yeah, that's it for the video. So hopefully you found this somewhat useful. And yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so if you, would check out the links to them, that would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.